In this video, we are going to now first create a little mesh, a little sphere mesh for our light to kind of show where the light is. And then we're going to talk about different kinds of lights and how each will affect the scene, basically, and how our shader will basically take these lights and calculate the general dynamic light representations in the scene. Before we get to that, let's first comment a little bit this code to make it a bit more clear to understand what's going on. So we had here added material to our ground plane, and then I created a node for my light. I haven't attached it yet. Then as child of root, then I created a light point, or rather created a point light object, and then manually set the position and the color of the light. Now what I'm going to do is I'm going to actually go here and comment out the position of my light, and instead attach the light to my node. So light 1 is going to be attached to the node 1. Okay, let's rerun and make sure that we do not have any compile errors or other silly problems here. Okay, fantastic. Now the difference that you see is now the light is actually kind of on the ground plane, so it's kind of hard to see it. So what we're going to do is we're going to make this light move upwards. So if you remember, so basically what I have is, so if this is the root of my scene, so I'm going to basically call this root. I created, as the child to it, I created my plane that goes all the way. And so if from the code, if you notice, we had placed this, I think, at -10 or something like that. And then I created my light. So my light is going to be a point that I created. So I'm going to create a node, and I'm going to make my node to be the child of root. And then so I'm going to use this as a container. And so I'm going to place the light inside of it. That's going to basically shine out, right? So in my code, this is how it looks like. So I created a node. It's the root manager. It's the child of my root scene node. And then I created a light, set the light type, set the diffuse color, and attached it as the node. And so the plane that we created is that's -10, obviously. So it's a little bit below. So we see a little light showing up. So then let's go ahead and translate the node about, let's say, 50 units upwards along the y-axis. So basically, effectively, which means that move the node with the light as attached to it upwards 50 units. Okay, fantastic. So we're going to compile this code and see how it looks like. So now the light should be higher, and so we should see a much bigger visible area on our plane. Okay, so it's so the light is a little bit more visible. What I'm going to now do is we are going to go and create another node and make that node the child of the node in which the light is present. So I'm going to create a node and move it upwards. And then in this node, I'm going to place a sphere. So that, and then I'm going to also translate the sphere node upwards so that I will be able to see the light kind of looking like that it is emitting off of this sphere. It's kind of like a visual illusion that's going to be created. So the idea is effectively create another scene node, place a sphere in it, and attach it to the node where the light is, and then move this node upwards a little bit so that you will see the light as if the light was coming off of it. So in order to do that, what we're going to do is we are going to go and create another scene node pointer, and let's call it light mesh node. And here I'm going to create it as a child of the node. Create child scene node. And I'm going to call this light mesh node. Then we will create an entity. And here we call it light mesh int. And it's going to be scene manager, create entity, and let's call it light mesh entity. Let's actually call these 0, 1, because later we're going to add some more to these guys. And here I want to make this a sphere. Mesh. So sphere.mesh is basically a mesh that is already within the media of our ogre. Or you could basically use a sphere, ogre sphere object to create this entity. And then we will attach our entity to the node. So light mesh node, attach object, light mesh int. The mesh will be pretty big, so we're going to have to also scale that. So we are going to need to scale, set scale of its node to, let's say, something like 0.1 f, 0.1 f, 0.1 f. Because the mesh itself is pretty big. Now, if we run this code, well, we should see that the light is still showing up, and then the mesh is created. But when we look at it from the vantage point of the camera that we already have in the scene, it's not going to really show up well. We would have to adjust our view because the light is going to be inside of that mesh, and we won't be able to see anything. So obviously, you don't see anything from here, but if you move up, and then we look downwards, now you see that there's this sort of black hole. We can't see anything. It's because the mesh is surrounding the light, and since the material on the mesh is not translucent, we will not be able to see the light. Or rather, that looks like it's kind of there's a black hole in there, so there's no light emitting out. There's a simple fix to this. All I need to do is just to move this light mesh node upwards. With the translate method. And if you remember from the previous unit, the translate, basically you have 3 spaces that you can translate. By default, you're in local space. So here I'm going to use just a local space, and I'm going to go upwards by, let's say, 20 units. along the y-axis. So now if I show this scene, you will see kind of like a half spherical object where your light is supposed to be. And it looks like the light is emitting out. Okay, so this is kind of a nice way for me to give a little mesh and a little visual representation to where the light is. So it kind of looks like I have a light bulb, effectively, in a scene that is emitting my light. All right, so the light that we have created here is basically a point light. And a point light is represented by a point in the space, and then it emits lights equally in all directions. So the light goes off in all directions, and then the intensity of the light will actually be proportional to the square of distance from the light. So the amount of light that, for example, a point in the space gets, if it is at k distance, k units away, will be 4 times more than another point that is located at 2k unit away from the point light. So it basically represents a inverse squared proportionality for a light, for the light intensity on a point light. There are, as I said, there are 2 other different kinds of lights that Augur supports. A spotlight is basically the same as a point light in that its intensity falls off at a certain rate, but the difference is that in a spotlight, this is basically my point light, but in a spotlight, you would have a cone that will represent the inner and outer areas for where the light will be represented. So the inner area, or the inner radius, represents where your light is going to shine at 100% of its intensity. The outer radius, on the other hand, represents where your light will reach %0 of our intensity. What that means is that inside of your inner radius, you get full light, and outside of your inner radius, or rather outer radius, you get no light. And then your light will fall off in between. And then your light will start falling off. So the fall-off parameter describes how much power the light loses when it basically illuminates the outer part of your light cone. So what that means is that actually, I shouldn't have called this fall-off. The fall-off is, so your light will shine here, but it would effectively start falling off to this value. So the outer radius, areas outside of the outer radius will get this much fall off percentage, rather. So your light will start fading out, so you get light all in here, in between the inner and the outer radius, and then when you go outside of your outer radius, then your light starts falling off. Okay, so now let's go ahead and change our light to a spotlight. So what I'm going to do is I'm going to now go ahead and create another light. We're not going to change our light. We're just going to create another light, and we're going to call that light a spotlight. So let's go and do another light pointer, light 2, and scene manager, create light, and we're going to call this light 02. Light 2, set type, LT underscore spotlight. Well, actually, light LT. Spotlight. Now, with the spotlight, I would have to specify its 3 parameters, actually 4 parameters. Its direction, where it will be pointing, its inner angle, outer angle, and fall off. And obviously, I would have to also set its color value as well. So we're going to go and set the light to set direction. And then for this direction, I'm going to use a vector 3. And I'm going to make this point downwards directly from the on the y-axis. Then we're going to set spotlight inner angle. And let's make this, say, about 10 degrees. And set light to spotlight outer angle. And let's make this about 60 degrees. And then we'll set the fall off to 0. Next, we are going to set the color of this light. And the diffuse color for this, I want to make this one a red light. So we're going to make it 1, 0, and 0. Now, the next step is to go and detach the light 1 from the node, and then attach light 2. And then just to also make this light 1 not shine in my scene, I'm going to set the light 1's diffuse color to 0, so that we will only have the representation from light 2 in our scene. Okay. Yeah, I hastily used the diffuse color method, and it used get instead of set. So now let's compile and see what happens. So now this time I should actually see a spotlight with red color, and so it would be creating a spot of red, and then the red falls off from the 10 degrees to 60 degrees radius around the scene, around where the spotlight is. It doesn't seem like my spotlight is falling off, so it's effectively showing as just a point light. Let's go ahead and take a look and see what is going on. Oh, let's make the fall off to 100%. All right, so okay, yeah, that was the problem. So the fall off was too small, or rather was set at 0. So our light will between the inner cone and the outer cone, it would not fall at all. So it would effectively be a point light. Now that we have 100%, the light from the inner cone to the outer cone, it effectively falls off almost 100% of its intensity. There are a couple of things I want to change with this to make it a little bit look better and neater. One is I want to change the inner and outer radius so that it would look a little wider. And also, secondly, I want to move this light a little bit upwards. Right now, I think the node that contains the light is only 50 units away, so the angles are small. And as you see, the size of this light, or the way that this spotlight looks like, it doesn't look round. It looks kind of like hexagonal. And that has to do with the number of sections and segments that we created with our mesh. So let's first change the segments problem. So if you notice here, the segments that we have, actually there used to be 20. So let's compile this with 20 segments in each direction, X and Y. So the light kind of looks, the spotlight looks very, it doesn't look round, it looks kind of polygonal. So we're going to move this light to, let's say, 150 units. Let's actually move this down after we attach our lights, and then increase our number of segments from 20 to 200. And as you see, it looks now more of a circular and more fine in its representations after we changed the angles. Then let's also go and change the angle to 75. And the fall off, we're going to make it to something like 85. So we have some values represented outside. Let's also change our angle a little bit as well. Okay. And let's make this 5. So our fall off is much less sharp. Okay, this should be a much nicer spotlight. Okay, so this is how a spotlight would look like. Now let's go and create another spotlight and another node and make it a different color and a different angle, or rather, I'm going to put the second spotlight inside of this node and just make it point at a different location. So let's go and create another light and call it light 3. And we set the light 3 properties almost similar to light 2. It's a spotlight. I'm going to make its angle to be -1, and then I'm going to make its degrees similar. Its fall off, we'll make it 15, and then its value, I'm going to make this to be a different color. And then we'll attach it to the node. So it should be a green color pointing at a different location on the scene. Okay, so now we have two spotlights. One spotlight that points with a green color to the left, because the x is -1, the y is -1, so it moves kind of counter diagonal to the left. And then the red spotlight, which is light 2, shows counter diagonal, or rather diagonal to the right. Let's move this actually a little bit down. So let's make it to about 50. And here we are. So the two lights shining. And okay, so before we move on to the directional lights, I just went ahead and moved up the spotlights, the node that contained the spotlights, to 150 units above the ground plane, and then changed the fall-off of my spotlights to 0.5 on both of them. So from inner radius to outer radius, the fall-off rate is going to be at a very, very small and slow value. And then let's check this result. And as you see now, since the fall-off is very, very small and slow, the cones look much sharper and much nicer in terms of how they look like visually. And obviously, the same number of segments have to do a lot with the boundaries, how round the boundary of my light when the shading is being calculated is applied. So that is how spotlights look like. Now next, we're going to go ahead and let's go ahead and just comment out my spotlights, light 2 and light 3. So let's comment all of this section out. And let's go and create a directional light. The directional light are different than both spot and point lights. One of the specifications of a point light and a spotlight is that they have a position. And so the position basically dictates how far or how much the light would fall off, rather would decay as you go away from its location. Directional lights do not have a position, and instead they have a direction. So these lights are very much used for things, for example, when you have, like for example, you want to represent an outdoor scene, and then you want to specify the direction where the sun is shining. So the source of the light in the directional light is considered to be far, far away from where the light is actually shining. So the position has no relevance to the calculations of the light source, and the only thing that has relevance is the direction of the light. So in the directional light, what we think about is that the source of our light is far, far away from us. And so the position wouldn't really matter. And so we usually use these as kind of like sun rays. And in the sun rays, obviously, the only thing that matters is the direction. Okay, so let's go ahead and create another light. And this light, we will call it a directional light. So let's also go ahead and comment out our light point as well. Okay, so we're going to go ahead and create another light. Light 4. And we call it light _4. And let's set the type of this light as light LT directional. Now that we have set it up as a directional, we are going to go and set its direction, which basically will give it just a vector 3. So light 4, set direction, vector 3, and let's make it to point diagonally. So it's going to be 1, -1, and 0. And then light 4, we're going to make this a blue light. So set diffuse color, 0.f, 0.f, and 1.f. And then we're going to make it attached to node. Edge object, light 4. All right, let's see how our scene looks like with this directional light. All right, so this is a blue light that is directional, and it's shining on my scene. If you notice, looking down on my plane, I won't see any decay on the light as it's falling off. And so if you apply a directional light on a plane, you really wouldn't see any visual effects, basically, that you would with a point light, because in a point light, you would see that the light starts getting decaying as you go farther and farther away from its perpendicular location on your plane. Obviously, with the spotlight, we actually saw the cones of our light shining, but with the directional light, you'd see a uniform color on it. Let's actually change this color to white so that it wouldn't look as offensive to the eye. So I changed the color to 1 for RGB, so it's going to look like a white color, kind of like the sun shining out. But as I mentioned, it is quite uniform. Now, with the directional light, you would actually have a direction. So remember when the little sphere that we placed for our point light? Now, on this sphere, you can actually realize the direction of the light. So the direction of the light is coming from the upper right corner of this scene, shining at almost a 45-degree angle. And that's exactly what we wanted it to do, at 1 unit for the x and -1 unit for the y. So it's basically a diagonal angle for our directional light. We're going to use this light in the next video to create shadows. So what I'm going to do is I'm going to wrap up this video here for the lights. We discussed the 3 point lights, directional lights, and cone lights. We saw how they look like. And so in the next video in this lecture series here, I'm going to go ahead and bring in a mesh, use a directional light that we have already established here, and then work with shadows. So I'll see you in the next video.